I'll see the bear. Wait. No, wait. Oh, my love, have you watched this? Huh? Then after you will watch it. See? He's very so cool.
Okay, and so I found something. If anybody has found any method, any shortcut, please raise your hand and you can contribute too. I would appreciate that a lot. But I'm going to share, please keep your videos off kindly. Okay, and how do I okay, so the shortcut that I found, I'm sharing with you. I mean, it's not a shortcut, but it's a method that will be helpful. For example, if we have a number 137, okay, and we want to find out if it's prime or composite. Now, we know the divisibility rules all the way till 10, right? And so we can check till 10, but for how long should we keep checking? Now, one way is if you look at the last digit, and if it is not even, if it is not divisible by 2, that means the whole thing is not divisible by 2. The whole number is not divisible by 2, right? We already know that. So we will eliminate 1 and we can eliminate 2 as well as its factor. Now remember, if we eliminate 2, that means all the rest of the other even numbers can also be safely cancelled. You know why? Because if, for example, let's talk about 4. If 4 is, kindly keep your videos off. How can you spotlight? Yeah, spotlight my video. Spotlight, yeah. Yeah, spotlight for everyone. No, yeah. Thank you. Okay, so if, for example, 4 is a factor of 137, that goes to say that 2 is also a factor of 137, which we just found out was not true, right? Because 4 itself is a multiple of 2. So if we are saying that 2 is not a factor of 137, that means none of the multiples of 2 can be factors of this number. So we can safely cancel all the even numbers. 4 got cancelled, 6 got cancelled, 8 got cancelled, 10 got cancelled. Okay, and then we can, so now we are left with pretty fewer numbers, right? Now we can write down a list of prime numbers: 3, 5, 7, 11. Okay, and then use the rule of divisibility rule for 9 to check if 137 is divisible by 9. Okay, and then by 3 as well. Okay, I mean 3 we can check here, but for 9 you can check the divisibility rule. You can use that and then see if 137 is divisible by 9 or not. Okay, so then we are left with these prime numbers. Okay, these prime numbers. So again, we will use the divisibility rule. So can you see how we have shortened the list of the numbers that we need to check? So that's going to save some time. How did I shorten the list? So I don't need to waste my time.
Not divisible.
Sorry, what was
3
that?
is also not divisible.
Yeah, okay. So yeah, I'm just trying to give you a a way to save time when in exam, if you want to find out if a number is prime or not. Can you please come forward? In exam, how to save time. That's my purpose right now. So now I have a shorter list, and so I will go ahead and I will test the divisibility rules. Okay, but still, till where should I go? Again, 14, 15, then I have 19 and so on. I have other prime numbers here as well. So I will only check prime numbers. Can you see I am only checking prime numbers? If a digit is not divisible by 2, I can cancel all the other composite numbers. Okay, I can check all the other composite numbers. If a composite number, for example, 9 is not a multiple of 2, then you go ahead and you check that divisibility as well, but otherwise prime numbers only. Okay, now till where should I go? That's the question, right? Now you should go, if you can find out their squares, if you can find out their squares, 13 square is
169.
13 square is 169. 19 square is, even if you don't know 19 square, leave it. You have 169, right? 169 is greater than 137. What is the square of 11? 121. Now 121 is smaller than 137. So that means you will check only till 11. That's it. You will check if this number is divisible by only these 4 numbers. If this number is not divisible by any of these numbers, that means this is a prime. You don't need to go on checking with other prime numbers. Why? Why is that? So as soon as you get a prime number, the square of which is greater than the number you're checking, you stop. Don't go ahead. Okay, don't waste your time. Now, why is that? Because we found out that all these are not factors. If they are not factors, then that means if you go farther than this, you're only going to get bigger numbers, and this is a way smaller number. So checking beyond a number like that is futile. Okay, so this is what I found out. Okay, so and I will share a YouTube video in which, from where I found this. I can share it in the group, and maybe you can also find it helpful. Okay, so I hope this helped. Did this help, Sidra? Okay. Okay, now let's get back to our highest common factor and lowest common factor. Now, in our last class, we discussed what a factor is. Remember what a factor was, right? When, for example, 3 multiplied by 3 2s are 6. 3 times 2 is 6. So 2 and 3 are factors of 6. Okay, so when we are trying to find out the highest common factor of, let's suppose, 2 numbers, let's say 18 and 30. So what are we trying to do? We have to find out what are the factors, meaning which numbers get multiplied by other numbers to give you 18, right? In simple words, in what tables do you find 18? Okay, what numbers get multiplied by other numbers to give you 18? Or you can say in simple words, in what tables do you find 18, right? So we'll start with 1, 2 9s are 18, 3 6 are 18, 6 3s are 18, 9 2s are 18, and then we have 18. Okay, then again, factors of 30, again we have 1 2 3. These are all the tables that have 30 in them. Okay, now then it's easy. This is called the listing method. We have as far as I know, there are 3 methods of finding out greatest common factor. This is one of them, listing method, and then we have the factor tree method, and then we have the prime factorization method. Now I will skip the tree factor method. Okay, we will stick to only listing and prime factorization. But if anybody finds the factor tree method more convenient, you go ahead and follow it. Okay, but in your book, the book mentions only these 2, listing and prime factorization. So I'm going to stick to these 2. And I find prime factorization convenient myself. So therefore, okay, so listing method is pretty okay and possible if you have small numbers like these. So this is possible, but if you have bigger numbers, then this becomes tedious and this becomes too lengthy and hard as well. So that's where prime factorization comes in. Okay, Now, these are all the factors. So let's complete this first. So these are all the factors. So which one is the highest common factor? So first of all, let's circle the common ones. Let's circle the common factors. And so of these 4 common factors, so we have 4 common factors, 1, 2, 3, and 6. Okay, I can write down common factors are 1, 2, 3, and 6. Of these, the highest is 6. Okay, of these, the highest is 6. So this is the listing method. Now, how can I do this using prime factorization? Let me do it here. Okay. So I'm trying to find out the factors which are common to both of them, and is highest. Which one is the highest of those? Okay. So again, we will start with the smallest possible number. Why? Because we are in search of, because this is prime factorization. Okay, prime factorization. Prime meaning not divisible by anything other than itself. So 2 is the smallest, and both of them are divisible by 2, and 2 is a prime number. So I will start with 2. 2 9s are 18, and then 2 1s are 2, right? 3 minus 2 is 1. I will carry 1 here. This becomes 10. 2 5s are 10. So this is division. Okay, I hope everybody here present in the class knows what I'm doing right now. If you don't know, then please raise your hand. Okay, now 9 and 15, right? Now they will go by 3, not by 2. Okay, remember, in prime factorization, while you are calculating highest common factor, remember the numbers that you are finding the factors of should be written together with a comma in between. That you should write them together, not separately. Well, you can do separately as well, but then, okay, if you want to do separately, then that's a little different. Okay, in this method, that the method that I am teaching you right now, we have to write them together. Okay, and we'll keep factorizing them. We'll keep factorizing them till the numbers do not go by the same single number. Okay, I'll show you. So 9 and 15 are divisible by 3. 3 is the smallest prime number that can divide both 9 and 15. So 3 3s are 9, 3 5s are 15. Now 3 and 5 cannot be divided by the same number anymore. They cannot be divided by the same number anymore. So I stop here. Okay, so I stop here. Whatever prime factors I got so far, I will multiply them. 2 multiplied by 3, 6. Okay, so that's how I calculated the highest common factor of 18 and 13 using prime factorization. Now, what if I factorize them separately? 2 9s are 18, 3 3s are 9, 3 1s are 3. Okay, so factors of 18 are 2 multiplied by 3 multiplied by 3. And then 30 would be, let me factorize 30. 2 1s are 2, 5s are 10, 3 5s are 15, 5 1s are 5, into 3 into 5. Okay, and then again, I will take out the common factors and multiply them. Okay, so this is the method if you factorize them separately. So what you will do is you will list down their prime factors and you will choose the common factors and multiply them. Okay, this is the method when you factorize them separately. Okay, so let's do a few practice. Okay, let's do 2 examples together. Okay, are you guys ready? Who wants to help me out? Yes, Sabiha, I like your hand. I like the fact that you come forward. Yes, let's do it together. Which method do you want to do? Together, separately?
Together.
Okay. Okay. So let's get started.
Both can be divided by 2.
Very good.
56 will be...
Yeah, 2 2s are 4, right? And so 5 minus 4 is 1. I carry 1 here, so this becomes 16. 2 8s are 16, right, Sabia?
28. Yes,
Yeah.
28 and 84 will be 42.
Yeah, 2 4s are 8, 2 2s are 4. Okay. Then
And now
again,
2 and if both can be divided by 2 again.
okay.
It will be 14 and 21.
2 2s are 4, 2 1s are 2. Okay.
And now it can be divided by 7.
Right. 7 is the smallest prime number that will divide both of them. Okay.
14 will become 2 and 21 will become 3. And now we have to multiply 2 times 7 and the answer will be 28.
Yes. So 2 2s are 4, 7s are 28. So the highest common factor is 28. Okay. Okay. Can we do it separately?
Yes.
Okay. Now somebody else. Okay. Muhammad. Yes. Muhammad. Yes, please be a
Yes,
little
ma'am.
fast.
Yes, ma'am. Yes, ma'am.
Yes, yes.
Yes.
Can we do this separately?
Yes, we can do.
Okay. Okay.
First we will do by 2 table.
Oh, okay. Come
The
on.
answer
Come on.
is
Yeah.
28 and
You
again
know
the
what?
2.
We will be reproducing this. We will be reproducing this. 2 1s are 2, 2 4s are 8. Oh no. Okay. So no, okay, no. So the yeah, so I was wrong. We are not reproducing, there's a little difference. Okay. So 56 factors of 56 are 2 multiplied by 2 multiplied by 2 multiplied by 7. Okay, Hania. Hania?
Yes, teacher.
Yeah, please do this 84 factorization of 84 real quick with me.
Okay, teacher, it is going to be divisible by 2.
Okay. Hurry up, beta, hurry up. Yes.
2 4s are 8, 2 2s are 4.
Yes.
Then it'll again be by 2. 2
Yes.
2s are 4, 2 1s are 2. Again, no. Now it'll be divisible by 3.
Yes.
The 7s are 21. And then you will do it by 7 and 1 will be, and
Okay.
then you will multiply it.
Okay. And so now what should I do? Yeah.
You're supposed to circle the common factors, which are 2 and 2 and 7.
Right. So 2 2s are 4, 7s are 28. Okay. So I think you guys are good at this. Okay. So should we move on? And then we can do the questions together. So let me just
Yes.
yeah, we can do the questions together. And another thing, if you guys have any question in the book that you cannot solve, or you have some confusion in, or have any problem, please tell me right now during the class, or even in the group, but even right now, even during the class, you can tell me. Okay, and we'll try to solve it together. Okay. Now, lowest common multiple. Now, what is that? Now, multiple is easy. Multiple, so factors were this, right? The two numbers that get multiplied are called factors. They are called factors, right? But the product that you get, this is called a multiple. The product that you get is called a multiple. So we can say that 6 is a multiple of 3, and 6 is also a multiple of 2. Okay? And we can say that 3 and 2 are factors of 6, or we can say 6 is a multiple of 2 and 3. Did you understand? So multiple is, let's suppose, let's do 30 and 36. Okay. No, 30 and 36 are big numbers. Let's take smaller numbers, because I don't know the table of 36. Okay, give me smaller numbers. Come on.
Teacher, 14.
12.
Okay.
14.
Okay.
11.
Okay, thank you. Let's do 12 and 18. No, 12 and 18 are okay. Just
12 and 14.
Let's take 6 and 3, okay?
What about 11?
Yeah, we can take 11 too. Okay, let's stick to these smaller numbers. Just for this listing method, okay? Then we will learn how to deal with bigger numbers. So 6 ones are 6 twos are 12, 6 threes are 18, 6 fours are 24, 6 fives are 30, 6 six are 36. Yeah, you guys better brush up on your tables, okay? Those students who don't know their tables well, they have to work on it, okay? Without tables, you cannot do this, okay? 6 six are 36, 6 sevens are 42, 6 eights are 48, 6 nines are 54, 6 tens are 60, 6 elevens are 66. By the way, I was also very bad at tables. When I was a student myself, I remember I learned tables when I reached, I think, grade 8 or something. Before that, my tables were not good. Okay, 3 ones are 3, 2s are
6 times 12 is 72.
yeah, 6 times 12, 12 is 72. Right. Okay. Jazakallah khairan. 3 fives are 15, 3 six are 18, 3 sevens are 21, 3 eights are 3 6.
3 8
The 7s are 21, 3 8s are
24.
24, 3 9s are 27, 3 10s are
27 and
30,
then 30.
11s are 33, 12s are 36. Okay. Now, this is the listing method. Okay. Okay. Another question. Why are we interested in the lowest common multiple? Why are we not trying to find out the greatest common multiple? Have you ever heard of greatest common multiple? Why don't we find greatest common multiple? Can anybody
Ma'am,
answer that?
can I tell Mohammed? Can I tell Mohammed?
Yeah, okay. So can you answer this question? Why don't we find out greatest common multiple? Why do we always...
Ma'am, because great multiples never end. They are infinite or more than infinite. That's why.
Very good. Yes, because you can go on and on and on, and because there is no greatest number, and therefore there is no greatest common multiple. Like you can go on and on writing these their multiples. You can keep on multiplying these two numbers by different numbers, and you'll keep getting multiples. Okay, so calculating that is not going to be possible. So what we are concerned with is the lowest common multiple. Okay, another thing. Why don't we calculate the lowest common factor?
Because the lowest common factor is 1.
Very good, because the lowest common factor is 1. It's always going to be 1, no matter which two numbers you take. Okay, so now you have this listing method. Let's see. This is the common multiple, right? This is the lowest common multiple that we can find. So here is your answer. You don't even have to find other common multiples because we are not concerned with them. They only ask lowest common multiple. Well, if they ask you to list the common multiples, well then yes, you will have to write other common multiples, such as, what are the other common multiples? Okay, 12,
18.
18 is common. Yes. If they ask,
24, 24, 30,
yes,
24, 30,
36.
yes,
and
very
then
good.
I think
Yes.
that's it, I guess. Maybe.
Yes, and 36. Okay, and then you can go on. Okay, so if they ask you to list the common multiples, then go ahead and list them. But otherwise, if they ask you lowest common multiple, don't waste your time. This is the answer. Okay, if they only ask you lowest common multiple, just write down 6. 6 is the common. Okay, so LCM is 6. Okay.
So then I don't have to list all of it.
Yeah, you don't have to list all of them, but sometimes they ask you to list. So this is the listing method. If they ask you, and if they mention in the question, you use the listing method, then you will have to do all of this.
So you also have to write all the rest of the numbers.
Yeah, I mean, they should mention in the question till where, the first 10 multiples, first 12 multiples, so you will follow the instructions of the question. Okay. Now, what is the prime factorization method of calculating the lowest common multiple? So,
You have to fun.
okay, now let's take the example of 30 and 36. Now we can, so prime factorization is good for bigger numbers. So we can take bigger numbers, okay?
Teacher, LCM instead of in LCM we prime factorize the multiple numbers
Yes.
until both are one.
Yes, both are 1. Yes.
Ma'am, you can divide them with 2, right? Or should we use 3?
No, you should use the smallest prime number.
So
Yes,
the smallest one is
It's
2.
two. Ma'am, it's two.
yes. So the smallest prime number is 2. So we will stick to 2. 2 ones are 2. You wanna, Sharik, Muhammad Sharik, you wanna do this with me?
Yeah, ma'am.
Yes.
I
Okay.
am.
Okay, it will come 15.
Okay. 2 5s are 10, 15. Okay.
Then it will, that 136 will come 18.
Yes. 2 1s are 2, 8 is 6. Okay. Okay.
These also divided by 3.
Yes. So now they cannot be divided by 2 anymore. And so 3. Okay.
Yeah.
Okay.
Then 15 comes on 5. 18
And
comes on 6.
3 6 are 18. Okay. And
They
then,
can be furthermore, both can be divided.
yes. Okay. So
So
we will deal with them separately.
yeah,
5
5,
5 are
1,
5. And we will
and
copy 6
6.
as it is. Okay.
Then
We
divided
can,
by 6. 1 and 1.
yeah. You know what? Now people might ask that, why are you dividing by 6? Shouldn't you be using the smallest prime number? Well, even if you now keep multiplying by, like for example, you use the smallest prime numbers, you will still get 6. Okay. Both of them get divided. So both of them will get multiplied to give you 6. Okay. So it's the same thing no matter what you do. So it will be the same thing. Yes.
I have a question.
Yes. Mohammed Sharif, please mute yourself. Yes.
My question is, my father, when we were learning this,
Yes.
he told me that you should always start from the smallest to the biggest. Like if like what you did, you wrote 5. You cannot do it by 2 or 3. He said like this: you can do it by 6, but not by 2 or 3 because that finished.
Yeah. Okay. So yeah, it's the same thing. Yes. So yeah, you can think of it that way as well. Yeah. Okay. See, in maths, you have more than one way of looking at the same thing. Okay. So yeah, you can say that, you go from small to bigger. And so you cannot, but this is, I don't know if this is a hard and fast rule or if it is true in all the cases, but maybe it is, I don't know. Okay. So yeah. Okay. So now how do we find out the lowest common multiple? We will multiply all these factors. Basically, the final answer will not be.
Ma'am, we multiply them.
Yeah, the final answer won't be affected whether you take them together or you take them individually. The final answer won't be affected. So 2 3s is 6, 6 5s are 30. Okay, 30 multiplied by 6 is, so let's write them down.
36, ma'am. 36.
Yeah, so 2 multiplied by 3 multiplied by 5 multiplied by, let's take, okay, 2 3s are 6, 5s are 30, 32 is 60, 63 is 180.
80.
So 180 is the lowest common multiple. Okay. Now I had this question in my mind, and I'm just sharing my question with you. Is that why? If you can answer, please answer. Okay, please answer my question. This is my question. Okay. Sometimes teachers also ask questions. My question is that when you prime factorize for LCM, lowest common multiple, you wait till you get 1, right? But for greatest common factor, you just stop where they don't get divided anymore by a single number. Why is that?
Ma'am, because
Okay. Yeah,
Ma'am, because when you do
listen.
LCM,
It would be better.
or
It would be better if you guys raise your hand.
ma'am, I don't know how to raise my hand, so I cannot like raise. I don't know how to raise my hand.
Come on,
Oh.
Zorez, you know how to raise your hand.
Oh,
Choose from the options at the bottom of the screen.
do you see my
Okay.
hand? I have raised it.
And another thing, those students who don't want to answer this question, please lower down your hand.
Okay, ma'am. So I wanted to answer.
Ma'am,
Yes.
can I tell?
Ma'am, I say that when you're doing the HCF or greatest common factor, it
Okay.
is because the HCF you're using the product of the common factors.
Yeah, you are using, oh, okay. Okay, you're using the product of the common factors. Okay. So product
Yeah.
of common factors. Okay. And in
Yeah,
LCM?
but in LCM, you will multiply the common factors and the uncommon factors.
Very good. Yes. 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 Exactly. So that was my question, and I got the answer, but I thought of sharing with you guys. So jazakallah khairan. Okay. So let's do a few practice questions. Okay. Okay. So let's do LCM. Okay. Is there any question from the book that you guys wanna solve here, or if you have any question, or do you want me to take some question randomly out for you? This is your book. You tell me which question.
Ma'am, go out for another
Teacher, I have
question.
some questions.
Yes.
Randomly.
Teacher, it's blurry.
Teacher, there was this class discussion thing for
Okay.
the. I was doing that just like that because I have, finished it.
Okay.
Finished the answers we did in class. And so I end up in one question that I really got stuck.
Okay. Which question was that?
That is what I'm telling.
Yeah, please tell me the question number, or if you can show me the question.
Yes, I'm telling. Just give me a second, please.
Okay.
Yeah. I did not understand the lowest common multiple of 63, 80, and 102.
Okay. 63, 80, and 102. Okay. Let's do it together. Okay. Okay, let's do it together. 63, 80, and 102. Okay, so here again we'll need our divisibility rules. Okay, we'll need our divisibility rules. Now we have to have a number that is dividing all three of them. Is that necessary?
No.
Yeah, that is not necessary. Yeah, that is not necessary. Yeah, in lowest common, nah, in lowest common multiple, that's not necessary. In greatest common factor, it is. Just like Zoray's right now explained us that in lowest common multiple, we multiply both the factors, whether common or not common. So it doesn't matter. Okay. So we can deal with them separately. Okay. So we know that this is divisible by 3. Okay, because 2 plus 1 is 3. This is also divisible by 3. 6 plus 3 is 9, but here we have this 80 that is not divisible by 3. And then these two are divisible by 2, but then this is not divisible by 2. Okay, so we will, let's start with 2. Okay, let's start with 2. So we will copy this as it is, because since it's not divisible, I will copy it as it is. And then 2 4s are 8, 0. Okay, does anybody want to do this with me?
I want to do it.
Me, ma'am.
Do it.
Who?
Ma'am, can I do it, Mohammed?
Me, ma'am.
Okay,
I am.
Mahil Ahmad Chaudhary, because you know he is raising his hand and he's quiet, so I'm giving him a chance.
To her, by the way.
Oh, Mahil. Yes, Mahil. Okay, Javeria, you. Yes, Javeria.
Okay.
Okay.
So it'll be
Come on, let's do it fast, okay?
51
2 5s are 10.
and 2 1 2.
Right. Okay, now.
40 is
Yeah,
divisible.
now you know these two are divisible by 3. Let's try 3 because these two are not divisible by 2. Yeah, we can do it even by 2. You want to go ahead and do by 2, sequence won't matter.
Yes. Okay.
Ma'am, I think it would be better if we try with 3 because then I will understand better.
Okay. Okay, Javeria, let's do it by 3. Okay.
Okay.
Okay, hurry up, hurry up, hurry up.
21.
Very good.
40
Let's copy this as it is. Okay.
Yes.
Okay.
And this is 17.
3 ones are 3. Okay, 5 minus 3 is 2. So this becomes 21. So 3 sevens are 21. Okay, now what? Now, okay. So we know this is a prime number. I know this is a prime number. So this is not going to go by anything other than 17. Okay. So let's stick to these two. Now this is divisible by 3, but this is only divisible by 2, and you know this won't go by 3. This won't go by 3. Okay. So yes, what do you want to take next?
3.
3. Okay.
7.
Okay.
We'll copy 40 and 17 as they are.
Okay.
And now by 2.
Okay.
It will be, we'll copy 7. It will be 20. 17.
Okay.
Now again by 2.
Okay. You know what? I think, okay, let's move on. You know what? This is going to take longer. So it doesn't matter, I think. Just 7. Okay. Okay, Javeria. You do it now. 17.
And 10.
Let's take 17. Oh, sorry, 17 ones are 17. And then now you can go on 2 5s are 10 and 5 ones are 5 and all of that, but you know you can just directly take this. But okay, let me take 2. 2 5s are 10. Okay.
Okay.
And then 5. Right? Right. Now you have to multiply all these numbers. You have to multiply all these numbers. Yeah, okay. So for first multiply the common numbers. So let me write it in the notation form. How many 2's do I have? 3 2's, 2 to the power 3. Oh, sorry, 4 2's. Sorry. So 2 to the power 4. 1 2 3 4. Beta 2 4s are nahi hai. 2 multiplied by itself 4 times. 2 to the power 4. So yeah. Okay, and then 3. How many 3's?
Power 2.
1 2. So 3 square. Okay, then I have a 7, then 5, and then 17. Yes, and then somebody told me that, you know, the sequence should be from smaller to bigger. Yeah, you can do that. You can stick to that. Maybe I got wrong. I mean, but the final answer is going to be the same. You can, you know, have 5 first, and then you can have 17 at the end. You can do that, but the
Ma'am, I have a question.
Yes, or is?
Ma'am, my question is, why did you write 2 raised to the power 4? This it should be 2 raised to the power 2 and then multiplied by 2 and then multiplied by 3 raised to the power 2, then onwards.
Beta, 2 to the power 4 just means that there are 4 2's. 1 2 3 4.
Okay.
Yeah, so it just means 2 is getting multiplied by itself 4 times. Beta, raised to the power 4 means that it is.
But ma'am, I didn't do the method you did. I instead of multiplying 2 with 10, dividing 2 with 10, I put 10 divided by 10 equals to 1. So is that fine if I write 2 raised to the power 2 multiplied by 2?
Beta, you are saying this 2 raised to the power 2 multiplied by 2. Is
Yes.
this what you are saying?
Yes. I instead divided instead divided 10 with 10 instead of 2.
10 with 10 instead. Okay. See, if you have something like this, you show me what you're talking about. If you wrote like this, it's the same thing. It's the same thing. See, you have the same base, so you add the powers. Yeah, it doesn't matter, you know, as long as you are, it doesn't matter what sequence you have. As long as you are multiplying all of them, you will get the same answer. Okay. So yes.
I learned that we are only supposed to use prime numbers, not composite numbers, and 10 is a composite number.
Yes, yes. So yes, you are right. Yeah. Yeah. Okay. So you know what? I was trying to save time because at the end, but yes, you should do the proper way. You should do the proper way. Okay. So 2 to the 4 to so what is 2 to the power 4? 2 to the 4 to the 8 to the 16, right? 16 into 9 into 7 into 5 into 17. So go ahead and multiply these numbers, and what you will get will be your answer. So yes, you guys are not allowed to use calculators, right? So you'll have to do it yourself.
No, miss.
Yes, I think calculator is allowed from the second semester.
No, no, grade 8.
No.
Second semester of grade 7.
From grade 7, second, not in grade 6.
No, grade 8.
I think in the second semester of grade 6 you are allowed.
No, in grade
No.
6
In
chemistry, we can allow, but
chemistry and
math we can't in grade 6.
We can do it in chemistry and physics.
Okay, now somebody check this answer. Is this correct?
Okay, teacher, I will check it now.
4 and then 3 square and then 7 and then 5 and 17. Did we do 63, 80 and 108? Multiply them again and check the answer from the back.
Yes. It's 85,680. Mom,
This was lowest common multiple, right? Yes. Yeah, okay, but just check from the back.
yeah, it's
Question number 2.
Teacher, the answer
Or-
came is
Yes, this is the answer. So Hania, did you understand this? Hania,
yes, I understood.
okay, so what was your confusion? Where were you stuck?
I was stuck on like 7, 40, and 17. This part I was stuck on.
Okay, so did you see how to get around that part? So so the numbers that are not getting divided, you just copy them. Okay, you just move on. Okay.
Yes, I understood.
Okay.
now. Thank you.
Okay. Then is there any other question that you guys want me to do, or should I choose myself?
You can choose yourself.
You can choose yourself.
Choose no.
Okay. Okay. Let me ask you a question. The numbers, I know this is a little blurred. I am doing question number 4, intermediate level. I know this is not in your SOS. We will take this question as practice. Okay. This is question number 4. I think this is not in your SOS, right? Is it?
Teacher, what is the page number?
Page, let me just check. Page number 21, and we did it.
Yes, this is page number 21, question number 4.
Okay, I found it. Thank you.
I maybe do.
Miss, it's not in my SOS.
Yeah, it's not in SOS because as long what I remember that they had only exercise 1B, question number 1 and 2. That's it.
You've done something like
Yes,
that.
miss.
Okay.
Yeah,
okay. So let's
we
do
haven't
this
done
now.
this.
You've done a question something like this.
Okay, so this question is saying, let me read this question. The numbers 792 and 990. So I have these two numbers, 792 and 990, are written as the products of their prime factors. Products of their prime factors in this way. So like they have done the prime factorization for you, okay, and they have written down the factors in this form, in the index notation. This is called index notation. The power is also called index. Okay, so 990 can also be written as, okay, according to Sidra, this is in SOS. So maybe it is included.
Yes, teacher, it's also recorded in my SOS.
Oh, okay, okay.
Miss, we did it.
Oh, you did it? Okay, good.
Ma'am, I'm getting errors in my calculation.
Which calculation, beta?
Yeah, the Javeria asked that what is the lowest common multiple of 63, 80, 102. I'm getting errors about it.
Okay. Okay, so let's do this. Okay. So
Can
now,
I just
okay. So how to do this? Can anybody, if you guys have done it, then you must be knowing how
Can
to
I
do
do-
this.
Can I do Ishal?
Can I do
Oh, okay. Oh, okay, Rafe. Rafe, please, you go ahead. Another marker.
First, the similar ones are 2 and 2.
Okay, so you are going for common factors, right? You know what I am doing? I will open up all the factors so that I can circle the common factors. Okay, because I want to circle the common factors, so I am opening this index notation. So I am writing the same thing down. So this was 2 cube, right? So I opened it 2, I multiplied 2 3 times. This was 3 square, so 3 multiplied by itself, okay, and 100. So I'm again going to do the same thing here, okay, and then now we can circle the common factors. Okay, Rafe.
2 are the common factors.
This 2, okay, and then?
And 3 are common factors, both of the 3.
Yeah, both of the 3s, yes.
And 11 are the common factors.
Yes, and 11 is a common factor. So then now let us write them down.
Multiply by 3 over 2. Sorry. Yeah.
Right, this 2, this 3, this 3, and this 11. Okay.
And the answer is 198.
So 2 3s are 6. Okay.
Yes.
3 11s are 33.
And
So let's multiply 33 by 6.
the
6 3s are 18. 6 3s are 18 plus 119. 198.
Yeah, 198. I told.
Yeah, so 198 is the greatest. Is it? Yeah, is it a common multiple or a greatest common factor?
It's common factor.
Common.
Yes, this is the greatest common factor. Why? Because
this is
yes.
GCF.
Yeah, why? Because we are only multiplying the common factors. If we had multiplied even the uncommon ones, then we would have gotten the lowest common multiple. Okay. Now, is there any other question you want to do?
Miss?
Yes.
Can you do question number 13?
We can do question number 5.
Question number 13. What page number?
Page number 22.
वाह 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 जवेरिया आप तो ऐसा क्वेश्चन निकालती हैं. Okay, so this is a word problem, okay, related to greatest common factor. Okay, let's see. A class has between 30 to 40 students. Each boy in the class brings 15 chocolate bars for a class party to celebrate Teacher's Day. The chocolate bars are shared equally among the 20 girls of the class and their form teacher with no leftovers. How many students are there in the class? Okay. Okay, this is a lengthy question, beta. This is a lengthy question, and to be honest, I did not prepare this, okay, for your class because I thought this is not included in your scheme of studies. But if you want me to do it, inshallah, I can do it in the next class. Okay.
We can do question number 5 of page 21.
Okay, question number 5 of page 21. Do you want help in that? Okay.
No.
Okay, the numbers 176 and 342 written as the products of their prime factors are this, hence find the smallest. Yes, that's a good idea. Because okay. So again, these are two numbers, the factors of which can be written in the index form. Again, the same way as we did the greatest common factor. But the difference is that here we will find the lowest common multiple rather than the greatest common factor. So 176 factors are 2 to the power 4 into 11. And then 342 can be written as 2 into 3 square into 19. So I am doing question number 5. Okay, I'm doing question number 5, page number 21. 2 to the power 4 into 11 and 342 is 2 into 3 square into 19. Okay, again, what I will do is I will open them up. I will open them up first. Okay.
Ma'am,
yes.
can you tell us how did you find 2 raised to the power 4 multiplied by 11? Because whenever you do this, I try to find out by my own by your method, prime factorization, but I always get errors. So can you teach me how do you find the answers?
Answer to what?
Answer to 176, like 2 raised to the power 4 multiplied by 11. How did you find this?
How? See, 2 to the power 4 means 2 is getting multiplied by itself 4 times. So can you see that
Yeah.
I'm multiplying 2 4 times?
Yes, I can, but how did you find them?
Find them. Okay, so now I will multiply them. 2 times 2 is?
2 times 2 is 4.
Yes. Okay, 4 times 2 is?
8.
And 8 times 2 is?
16.
And 16 times 11 is?
176.
176. Okay, I'm using the calculator to save time. Okay,
Oh, that's how you did it.
See? See? Okay. Okay, so yeah, he can come upstairs. It's okay. Okay, so now I will circle the common factors, and that's that. Okay, so that's a common factor, and then, okay, how do we?
What can I do with you?
Miss will not do anything with the rest of the 2.
Teacher, can I do with you?
Wait, sorry?
We will not do anything with the rest of the 2.
Nah, yeah, let me figure this out. Wait. You know this listing method thing? Wait. 2 and then this 2 and then this 2.
Teacher, it's actually 2 by 2 because like there's nothing down that can multiply with the same.
No, you know what? We will multiply these 3 2, these 3 2, these. So remember, Zores told us, yeah, whose video is on? Who is this? Zores, is that you?
Ma'am, I'm Zurez, not Zores, but yes, I did it.
Yeah, why did you? Why did
I
you?
done it off.
Yeah, you better not do that. Okay, and I thought you were Zores. Acha, okay. So now remember, was that you who shared with us that both the common and the uncommon factors will get multiplied, all of them? Okay. So what am I doing? This is the 2 that is common. These are the 2s which are uncommon. So both common and uncommon. And these are the 3s which were uncommon. And then this 11. And then this 19. All of them. Multiply all of them. Tell me the answer. Tell me if we get the correct answer. Into 3 into.
Ma'am, what about the underlying things we have to calculate, or plus the common factors as well?
Multiply all these numbers.
Okay, then I'll multiply them.
Okay, tell me the answer.
Yes, this is correct way.
Sorry?
This is the correct way.
I cannot hear you. Are you saying this is the correct way? Ask him to do
Yes.
that. Okay, so yeah, please check the answer from the back. Is my answer correct? Please check. Yes, it is. Okay, I just checked. So this is how it is. Okay, so you took the common and you multiply all the common as well as the uncommon. You multiply all of them. Okay, and so you will get this. The answer that you get, that will be the lowest common multiple. Okay, is there any other?
Teacher, can you just explain this again?
This part?
Yes.
Okay, so remember, okay, so this is another method of finding out LCM. By the way, I did not explain this before, but remember, we used to find LCM this way, right? This is what I explained to you, prime factorization, right? You keep dividing them, and it's not necessary that both the numbers should be divided by the same number. You keep dividing them until you get 1, right? Why we would do that is because we are multiplying both the common and the uncommon factors. So we listed all the factors because the factors were already given in the question. So we listed them out. Okay, we opened them up. And then we took out the common 2. Okay, we took that one out because only only this 2 was common. The rest of all the factors were uncommon. So I took this common factor out, and then I multiplied with the rest of all of the uncommon factors. So I took these 3 2s, these 2 3s, this 11, and this 19. I multiplied them, or I multiplied all of them together, and I got this answer. If you do prime factorization way, you're going to get the same answer.
Ma'am, I'm getting 30,096 with a
Yes.
0 on the question.
Yes, please raise your hand. You're the only one who is speaking without raising your hand and out of your turn.
Ma'am, I am raising my hand.
Can I
I might have
Mohammed?
Yes, okay, Muhammad. Yes.
Ma'am, you will do this with 2.
Do this with?
The 2 means these both will divide by 2.
Yeah, okay. So you want to do the prime factorization way? Well, you can go ahead and do them, okay, and you will get these factors. Okay, but the question had already given us the factors. Okay, so they wanted us to show this way, this method. Okay,
Okay,
so
ma'am, I will tell you. Like we will choose when this is highest common factor or lowest.
this is beta. This is not highest common factor. In highest common factor, you will only take the common. That's it. You will only take the common. Yeah. Okay. So,
Ma'am, we will take 2 and
the highest common factor, I think, would only be 2.
yes.
The highest common factor of these 2 numbers would only be 2.
Yes, ma'am.
Okay. Okay. Is there any other question?
No.
Yes, teacher, I have a question.
Yes.
It is on page number 16 of our book, practice now 10.
Okay.
Find the highest common factor of 90, 135,
35 and 270. Okay. Let's do this.
Miss, I'm confused how to do the lowest common factor ones.
Sorry?
I'm confused how to do the lowest common factor questions. This one, the one we just did.
Okay, this is lowest common multiple, not lowest common factor.
Actually, multiple.
Okay, this?
Yes, this one.
Okay, don't get confused by this method. Okay, did you understand the prime factorization method?
Yes, I did.
Okay, so if you understood that, so what they did is that they factorized each one of them separately. They listed out their factors, okay? And then we have to multiply the common and the uncommon. So you take out common, okay? You will not take them separately, but you will consider them as, you will take one factor, one common factor. I mean, here the common factor is 1. So you will take the common factor and then you will multiply with all the uncommon factors, okay? Don't get confused. Keep practicing, okay? Remember, practice is key in math and in all the science subjects. Okay, let's do this HCF of, now this is the last question because now we're running out of time. I will do this last question. If you still have any problem, you can ask me in the group, okay? And then I will answer you individually, okay? So let's factorize them together. 135 to 70. Okay, using the divisibility rule, we know that all 3 numbers can be divided by 5, right?
Yes.
And also by 3.
Also by 3.
Yeah, also by 3. Okay, so let's do by 3. Okay, 3 3s and 9, 0. Okay, who said that they were finding this? What was that, you, Hania?
Yes, that was me.
Okay, then you do it with me. so that you understand. Okay, so then 3 4s are 12, right?
Yes, 3 4s are 12.
3 5s are 15, 3 9s are 27, and I told you we can take the first two digits together
Yes.
without adding any zero. 3 9s are 27, and this is 0. Okay. Then again, we can see that all the three numbers are divisible by 3, so we can continue with 3. Okay. Right, Hania?
Ones are 13,
Okay.
two
3 1s are 3.
1s are 3, 3 5s are 15. Then
Okay.
again
Can
we
I
have
continue with 3?
yes.
No,
No,
10.
ma'am. 5 is better.
No,
5 is better.
you can't.
Because
5.
you see, 10 is not divisible by 3.
Ma'am, what about 10? What about 5? Sorry. What about 5?
Okay, Hania? So I will
Yeah.
divide by 5. 2s are 10, 3s are 15. You know
2,
what? If
3,
you
and then
if you guys will misuse this option that I allowed you to unmute yourself, I will remove this option. Okay, then you won't be able to unmute yourself. So please don't unmute yourself unnecessarily, and do not speak out of your turn. I'm doing this with Hania only. Okay, Hania. So now we have 2, 3, and 6.
Yes.
Okay, so now tell me.
We can't do this. Is we have to end here.
You're right, because for greatest common factor, all the numbers should be divisible by the same single number, right? So, okay, we will stop here. So we have 3 3s and 9, 5s are 45. Okay,
Yes.
so sorry, 3 multiplied by 3 multiplied by 5. 3 3s are 9, 5s are 45. Did you understand?
Yes, I understood.
Okay. Okay then. Okay, I'm ending the class. If you have any query, please ask in the group, okay?
Teacher,
Yes.
my mother messaged you privately. Can you please check that message?
Yes, sure. Okay.